All right, good morning, everybody. My name is Sailu, and I have with me my colleague Jagan. Will be presenting today about data immutability. Um, let's see. So we will define what is data immutability, what is data retention, and how it can be implemented in general. This is a pretty generic talk. We will mention a couple of our implementations in our system, but mostly it is going to be very generic concept about what is immutable data. And at the end, we will give you a couple of examples of what we do at Dell Data Protection Division. Right. So, where am I going? All right. So, immutable data. Basically, basic definition of immutable data is once written, it cannot be modified or it cannot be deleted. It can be read. Of course, it can be read multiple times. Right. So, why is this important? Because we have we have many customers that are under either regulatory requirements, or they want to retain data themselves because of self-imposed restrictions. There are U.S. government organizations such as SEC or FINRA or Sarbanes-Oxley. All these are European GDPR. All these regulatory commissions, they impose certain type of retention periods on certain types of data that industries generate, right? So for that duration, let's say 2 years. For example, if they have to keep their tax records for 3 years or 5 years, and their companies are required to do so, and companies are required to keep them in a place that cannot be the data cannot be modified or deleted, right? And most companies have their own self-imposed restrictions as well about policies as well about data retention, right? So basically, So we work in the Dell Data Protection Division, which we are the secondary storage, we are the backup. All right. So usually you have the primary data, file systems or NAS or SQL or whatever you have you, and we also, the data center in the ecosystem, there is a backup application that kind of drives the backup of the primary data. This is usually the backup storage, the hardware. This is, for example, this can be a Dell Data Domain or anything similar. And the backup application usually has backup. The customer, the backup admin sets these policies. I would like to back up, every day or every 6 hours or every week. Incremental backups daily and full backups weekly. Any such policies are stored in the backup application, and it is the one that is orchestrating all this backup, right? So in the backup storage, you have these point-in-time copies. Usually these copies, they are not modified, but accidents can happen or ransomware can happen, and we were talking about yesterday. Eric mentioned about the number of ransomware attacks happening every day, and they will immediately go to the backup system and try to delete that first. So this is where it is especially important if you are under a lawsuit to be able to keep your data. So this is where the immutability comes into play. Right? So I don't know why we use this, because hackers don't look like this anymore. They just look like you and me, But anyway, so we were researching some, Eric mentioned the latest data, even for August 2023, I remember yesterday that Eric was mentioning, but for the 2022, 25% of all breaches are attributed to cyber attacks, and the loss for each attack is about $5 million. That is just cyber attacks. These are usually destructive. Their main goal is to just delete the data. Where as opposed to ransomware, they don't want to delete the data. They want to make money out of it. So the common way that they do is they log into the system, they hack into the system, and then they stay there. They figure out who are all the players, and they steal the passwords or whatnot, and then they encrypt the data. They encrypt the data, and then they will want money for to decrypt them. And even here, the average loss is about $5 million per attack. Right? So this is a very common way. So let's say you have a backup application that is copying point-in-time copies, right? And they have copy 1, 2, and 3. These are all good copies. But then a ransomware attack happens, and they log in and they encrypt the data. And the next, so they keep, if it is ransomware, they don't change anything. So backup 4 and 5 are encrypted copies, and the key is with the ransomware guy or girl. And then they delete these copies. So once this happens, there is no way to recover from it. These are deleted, and they can recover copy 4 and 5, but they're all garbage. Or another way is that the sysadmin made a mistake. There is a cron job that's gone haywire, and they've used the wrong path to delete something. They've used the wrong name to delete. And these are also very common. So there are many situations where the backup data, this is supposed to be the backup of the data of last resort, and the data of last resort is gone, right? It's unusable. So now they are dead in water. Right? So how do we make the data immutable? Well, this is a poor man's immutability, right? You can use the file system, you can make all your files read-only, right? But that's not protection at all, but because the hacker can get into the file system and then just make them read-write. And if they have enough credentials, they can just toggle the read-only mode, and they can do whatever they want with it. And there is also no duration associated with this read-only, because remember when I talked about the regulations, the regulations always come with duration, 3 months to 7 years or whatnot. They want, for that duration, they want the data to be read-only, immutable, but after that, that data can be deleted. So that's why most file systems or storage systems implement what is known as retention locking. It's also called write-only, read, warm. Write once, read many times. So this is way better than making the files read-only. Here, once the data is written, you use an API to set the retention lock on it. Once the retention lock is set, you have policies that say how long the lock is alive, and for the duration of that lock, there can be no modifications and there can be no deletions. And there is no way to toggle this. We'll talk about it. There are 2 ways to do the retention locking. There is a governance mode and a compliance mode. The governance mode is, I think I talk about that in the next slide. Right. Okay. So the governance mode is less restrictive. This is for the companies that self-impose the retentions. So this, with an administration privilege, they can revert the locks before they expire if needed. But the compliance mode it's a one-way street. Once locked, there is no way to unlock it until the duration, until the lock expires. And the compliance mode also comes with another feature called the legal hold. The legal hold means that even if you say 5 years of duration, lock duration, and even after before the 5 years, if there is a case against them, and if they have to hold the data even after their retention period, you can use an API to place a legal hold, and the lock will stay on until you remove the legal hold. So that's a special feature that, in fact, the SEC regulations require to have this feature. So there is you can get certified, just like you can get certified for FIPS. There is also a certification process to be able to comply with. You can say that your product complies with SEC 17F4A, and there are some third-party companies that help you get this certification. Question? Yes.
Yeah. Do you have to interact with the opposing requirements of the right to be forgotten?
Can you say that again one more time?
Do you have to interact with the legal requirements of the right to be forgotten?
The right to be forgotten. So those are they mutually exclusive?
That's the issue, yes. Not necessarily.
We never had a question like that before.
Well,
I'm stumped.
So you are, the concept of right to be forgotten, primarily out of the EU, is not universal. You are actually not obligated to get rid of every record. If it's required for sort of business transactions, there's a whole set of exceptions.
So
that just because you said make it go away doesn't mean it's going to go away. You may have to respond, but that doesn't necessarily mean you got to get rid of it.
So the question is, what about the right to be RIGHT, the right to be forgotten? As far as the SEC 17F or FINRA or the GDPR, when it comes to the retention, we're following that. If the customer comes and says, I want to forget this, we never do. We have customers that said, okay, I'm done with this system. All my locks have expired. Can I delete? Can you destroy this system? Can you decommission the system? Even then, we cannot take the customer's word for it. And if they have 1 million files on the system, we're not going to go and verify 1 million files to say whether the lock expired or not. We always tell them, it's your job to make sure that the locks are expired and you delete the files yourself. We're not going to delete the files for you. Make the file system empty, and then you can destroy it yourself. And if they keep on insisting it, almost always we involve Dell Legal, right? So as a file system, we won't delete anything for the customer. It has to be customer enforced, customer initiated operation. So with the immutability, with the data immutability in place, so the flow will look like this. The first step is that the backup application, it discovers the storage, it adds the storage, and then they create policies. The policy being which assets need to be backed up, and then how they need to be backed up, how many times, the frequency and the duration. And then they start the ingest, they back up the systems. And once every file is backed up, then they use our retention lock APIs. And then they explicitly place locks on every single backup that they do. And then the backup application is responsible because this backup application, so there are integrated systems that come with the backup application, or there can be target systems where the backup application can be a third party, but they can use the same APIs. And they are responsible for cleaning up old backups. Because once retention lock is turned on, we turn off mass deletes, right? There is no way to delete an entire directory if the directory is not empty. Even if the files in the directory are all unlocked, we will prevent directory deletions or file system destroy. All those commands are blocked once the retention lock is turned on, because we don't want to take that responsibility or liability to accidentally delete something that is still locked. Yeah, question?
So are the locks applied at the sort of the backup side of things or on
Yes,
the primary data?
on the backup side. You see, we cannot lock the primary because the primary keeps on changing, right? They have database, and that database is always changing. So what they do is, to meet the requirements, they do point-in-time copies, and then they lock the copies. Right? So with the understanding that if there is a disaster that happens between T1 and T2, the understanding is that you can go back to time T1 point-in-time copy. Yes?
So I'll try to speak up loud enough.
No, we need it for the recording.
Okay, that's fine. To his point in your answer, and by the way, I work a lot with Dell technology, so I understand what you're talking about. But there is a gap, right? So if I create a financial record in the primary data side, there's a period of time before it's going to get to that backup storage, either whether it's about a backup or however it happens. And it's not about disaster; it's more about somebody modifying that record and saying something that's going to make the financial reporting skewed or whatever. How have you seen customers deal with that gap? Because that's really the one that violates the SEC rules of financial record keeping.
So this retention lock is always a shared responsibility model, right? So it's not like, if Dell provides a product that says we are retention lock capable, that doesn't absolve them of the protections that they need to make to the primary side of the data. Our responsibility is, once the data lands, we will protect it. And if you have a daily backup, then our guarantee is that, if you have backup today and the backup tomorrow, if something bad happens in between, then we will guarantee you that we'll give you yesterday's backup, if today's backup hasn't happened, right? So what happens to data on the primary side before it reaches us, we cannot protect it, and it is up to the customer to protect their primary data.
Well, I'll add one thing just to help you out on the slide, though, because I've done this with your technology. So there are technology. One of the first uses of immutability really was the email systems, right? So and there's in Microsoft Exchange there's logging, right? There's the journaling of that. SQL Server's got log shipping, so you could send transaction logs as they're going. In file systems, there's file system filters that, as things get changed, can go down. And I have seen your technology has been used with immutability to protect that gap. So something that you may want to think about for the future.
Okay, cool. So I'll let Jagan take over from here.
Thank you, Shalu. Yeah, this slide is like more on what we saw earlier, where we projected that how the backup copies were destroyed, and there was no reliable copy left to recover in the event of a attack or any attack. Now here, let's add immutability to the whole context, right? So the backups that earlier happened were without immutability. Now we have immutable copies, that is good copies or reliable copies. So in the same event, let's say the ransomware attack happened and the encrypted copies came back into the backup server, which is like copy 4 and 5, the red ones. But we still have copy 1, 2, 3. And the attackers cannot destroy them because they are locked, right? So we still have 3 reliable copies available now because of immutability. And at this event, the admins, what they would do is like, they would restore the last known good copy, which is like copy 3 over here, and they have something. Earlier, they didn't have anything, and they had to either pay the ransom or they had to start from fresh. So it was all chaos over there. But immutability came into the rescue, and it prevented all those good copies from being destroyed, and then we could recover something. And accidental deletes, now that is completely out of scope because they are locked copies, and nobody can delete them whether intentional or unintentional. So that is also safe. So this is how immutability comes into aid when per ransomware or cyber attacks, right? Which is common nowadays. Okay, till now we saw the benefits of immutability. Now let's see what are the attack vectors or challenges, because with the advancement of how we protect data and all, so are the hackers and the attackers, right? They are also going intelligent ways and trying different ways. So let's see, okay? The first and the foremost, just because we use immutability, it doesn't mean that, and it can be protected, the data can be protected by, from any kind of attack, right? Let's say, for example, the data center. If we leave the data center room open and we tell that, okay, data is locked, it's not going to make any thing, right? Anybody can go inside it, they can damage the disks physically, shred them, or they can do whatever they want. They have physical access. So this is one of the most important aspects where the customer have to have a shared responsibility model enforced. They need to ensure that the physical protection of the data center, which is under their control and not the other vendors, right? They have to ensure it is completely protected. Like, for example, they need to have proper access controls, refreshed access controls. They need to give the control to the people who need it only, and they would revoke it as needed. They would have some kind of a policy in place, right? Otherwise, that as long as the physical access is broken, then it is the biggest problem area right there. So that is one point. And the second is like data is locked, that is true. But then what about the management operations, right? For example, destroy the file system or do some management operation which disables something in the backup server, right? So these are a certain other aspect which needs to be protected as well, along with the data. So this is where, if you remember in the earlier slides, you mentioned about dual sign-on, where a certain operation now requires 2 users instead of the regular administrator user, right? So 2 users means one is the system admin, whoever is already there. The new one is the security officer, right? And the requirement here is that, okay, both of them have to be 2 different persons or individuals, right? The same guy cannot hold the keys for both and act, then there is still a single point of failure. So if there are 2 persons, 2 individuals, then the whole attack scenario reduces because both of them have to go raw, right? So that is one way where most of the destructive or critical management operations in the backup server are protected, right? Because apart from the data, they also need to be protected. And dual sign-on model is a mandatory thing that is seen in compliance models, right? Compliance variants of retention locking. And even the dual sign-on, right, is enforced in a better way by adding multi-factor authentication. Like apart from the passwords, we have to have a MFA kind of like auth code or a SMS or some kind of secondary authentication model to make it even stronger, right? Because imagine a backup server with a terabyte or petabyte of thing, and you have a file system destroy operation, right? You need to protect it as much possible. So that is one aspect. Okay, now immutability of higher retention locking provides a guaranteed protection for the namespace level attacks. And namespace level attacks means like modifying, overwriting the data or deleting it or renaming it, any such file system operations, right? Retention log will prevent every such of them. But what about the layers around below it or above it, right? Namespace is just the only layer, but there are a lot of layers, if you see in the right side, below it, which can be and which are exploited by the attackers, right? We'll go through them one by one and see how the attacks happen and what are the best practices or recommendations that backup servers can follow. So let's start with the first one, clock and NTP, the biggest one, the oldest one actually. So as we know that the data is locked for like certain duration, 3 months, 1 year or something. Some attacker comes and then moves the clock ahead by that much time, 3 months. Now they can delete that locked data prematurely before its real expiry, right? So this is one of the most commonly available, and if they gain access to the console or the cell of the backup server, they simply go ahead, move the clock to the desired time and then go and delete all the data because they are now expired. The locks have already expired. And same with like NTP servers are a bit difficult to crack, but as long as they're like external and outside, located outside in some other data center or some other system, they can have poisoned NTP servers, or they can make the time bad in that NTP server, like which will eventually sync to the local systems. Yeah, there are limitations on how much data can come in the offsets, but still it is like one of the ways that can be exploited to move the time ahead and prematurely delete the lock data specifically. So something that we see and we even use is like restrict the frequency and amount of time that can be changed. Because these are backup servers and we are talking about time, right? It is a very crucial attribute of any data that is present there. So the need to change a time by a long amount or multiple times is very rare scenarios. So we restrict, like, okay, you can change the time by 1 hour at one time and only once in a day. Just an example. This will restrict or at least reduce a lot of attack scenarios. Because now to change for 3 months, those attackers have to try this on every day for multiple days. And by that time, somebody will be notified, like alerts will be generated on each change. So a lot of noise will be made when this happens. So that is one thing. Then you bring all the time management or NTP management operations under dual sign-on. That will give additional layer of protection because now 2 folks are involved and they have to accept that, okay, we're changing the data or NTP settings or pointing to a new NTP server. So that is another thing. So these are some of the common ways where like we can have some protection layer, additional protection layer. Next is the operating system. Any backup server software stack should be running on the operating system, whether on a bare metal system or a virtual machine, the OS has to be there. If the attacker gains access to the OS cell or the bash cell or whatever console cell is there, right, then they have access to a wide range of destructive CLIs, commands or ways, methods, right? They can go and wipe the disks holding the locked data. So it doesn't matter if the data files are locked in the namespace. They're wiping the disk at a disk level. For example, the famous DD utility in Linux, right? Just go and wipe and write garbage to it. All locked data is gone. So similarly, they can destroy the partitions, what not they can do when they have access to the OS cell. So, and there is no dual sign-on in any OS as such, right? So for this, protect that root OS console by any means because nobody needs to access to that. Backup servers will always come with their own cell or a custom-made administrative console, something like that. Need for a root cell is very, very rare and only seen in case of support scenarios and other troubleshooting things. So always restrict that root cell, like get it with a time-bound unique token, which expires in like 3 hours, 4 hours, or 1 hour, which can be derived from a support system or a support personnel. Put some kind of gate there. It need not be open, right? So that is the key point there. Then hypervisors, which are very common nowadays, right? So the virtual editions of the backup servers, which you see more and more nowadays, right? They run on a certain hypervisor. So the OS is running on a hypervisor like VMware or Gen or Hyper-V or anything, you name it, right? So there, now the attack moves one layer down. Here the virtual disks or the virtual configuration or even raw devices which are exposed as a pass-through mode, right? These all can be controlled in this hypervisor layer. And they can do the same kind of disk level destruction if they gain access to this hypervisor console, maybe it's GUI or the UI or the CLI, anyway, or the APIs, right? They can do any destruction, like they can delete the virtual disks, done. Or they can write garbage to the pass-through device, the SSDs or the NVMEs or any storage device. So one option that we see provided by the console hypervisor providers is that a lockdown mode, at least VMware provides that, where they cut off all the access points to that hypervisor and only keep one access point alive. And by all the access point, I mean the CLI, the real console, the GUI, or the APIs, all these are cut off. And there is only a vSphere console which is accessible to a certain whitelisted users. That will cut off a lot of interference or attack scenarios, because people just try to get into the available doors. And if you close the doors, right, it will like reduce a lot of attack scenarios. That is one thing. We're going down one more level, right? All these guys will have a bootloader, something other. We just give example of the Grand Unified Bootloader or the Linux loader, which are the oldest guys. And here, what threat these have, right? If somebody gains access to a bootloader console, first thing, they can enter into the single user mode of the OS, whatever OS it is, right? It might have a way to have a single user mode where the whole OS cell is exposed. Second, the bootloaders have advanced so much in the last decade, right? They have tons of functionalities exposed in that console itself, like disk level functionalities, formatting the disks, setting up the root device, whatnot, right? So many destructive operations can be done directly in the console itself. So this layer has to be protected, because in a general or regular working scenario of a backup server, accessing a bootloader or going into the console is more on support scenarios only, to fix something or if something is badly broken, right? So here, what we see is that just lock that bootloader console completely. Don't allow single user logins via that console. Don't allow console access directly via that interface. Instead, provide a third-party USB key kind of facility, right? Which somebody has to go into the data center, some legitimate person, along with the information from the support folks of that vendor. They'll plug it in something, and another bootloader can come in and you can access the system from there. That provides another prevention of another attack point, which could have been misused. The lowest level, these are the platform management interfaces. These are mostly on the motherboards of the servers as HTTP servers running to facilitate remote management of the system, right? We have seen like Dell IDREC or HP ILO, IPMI. All these are very popular for all the admins who wants to manage the data centers away from the dark rooms, right? So these have advanced so much that these provide any kind of operations in the very base layer, like forming RAID groups or destroying RAID groups, initializing disks, offlining disks, anything can be done, right? And the attackers here in our scope of target is like to destroy the log data, like compliance log data, let's say. They simply have to log into this interface, go and destroy the RAID volumes, write junk to them or recreate new volumes, do whatever kind of destructive operations, right, which can completely wipe out the whole lot of data. So this is another door where people can enter. And this is generally open because they use it for monitoring purposes, right, the health of the system and other such things. So the chances of this being open is much, much more, right? So here what we say is like, you disconnect it as long as you don't need to monitor it. A lot of our customers also generally disconnect the Ethernet cable directly, right? We don't need it. Or if you need the access, then we have to harden this layer. How do you harden? First, harden the root password. No need of the root password as long as you are not going to reconfigure it in a large manner, right? And have one or two users which are in disabled state, right? And let the backup vendor control how to enable that, right? It should not be just a straightforward thing to enable a user here. There should be a way or an authenticated mechanism with like a unique key, right? Time-bound unique key. Somebody should provide a time-bound unique key. Then you enable one user for, let's say, half an hour. Then the support folks can use that to log into the interface and do whatever they want. Some kind of control has to come over here. That's the key point.
So again, one of my pet peeves is, not only that, you can also go cryptographic
Yes. Yes.
Dell conversation. We are also, is there any consideration for a security officer role for the iDRAC?
Yes, yes. So what? So in the last point, if you see, right, what we generally follow, right? We when compliance is enabled on a system, we wipe out each and every existing user in the ID rack, and we randomize the root password completely. Nobody knows it, and it keeps on randomizing every 5 minutes, right? That is there. Now we let the customers define 1 or 2 users or their own choice with the username and the password, but we keep them disabled. Okay. Now, when they want to access the ID rack, they have to go to our Dell cell, okay, and they have to enable the user, and that requires the system administrator password as well as the security officer password, 2 persons. And we enable that only for a time limit, like 15 minutes or 30 minutes or 1 hour. A max limit is there. So that is the restriction we have put. Thank you. Okay. Now, seeing all these attack vectors, right? It makes more and more sense if everything is integrated in one box instead of having different parts, right? So that we can, a particular one vendor can harden everything in every layer. For example, if you see over here, right, on the right side, this is one of our models of Dell, DM5500. But if you see here, the backup application is there, the backup server is there, which is DDB, the grub layer is there, the hypervisor is there, it's a VMware, and then the ID rack is there. Now, all these layers are hardened as per our own best practices that we consider as good, right? Nobody can access the ID rack layer, users are disabled, grub is locked completely, hypervisor is in lockdown mode, and the backup server, which is the data domain virtual edition, it has its own clock hardening, a secure clock to detect clock skews as a third level of defense. The operating system cell is hardened, okay? So all these features, and the backup application is integrated in this box so that it is not a separate box out there. Everything is in one cell. So in this hyper-converged or converged appliance model, right, lot of vendors, they have the new, like, they have the specific ability now to control a lot of access points, right? And as a result, secure the whole thing to a much more better levels, right? Okay, now we'll see 2 use cases, okay, where immutability is very commonly used. First thing, this would look like the typical backup workflow diagram that we saw earlier, but if you see, there's a copy data management, there's a backup application over there, and there is the assets are over here, and this is the primary backup server with immutability enabled. Let's say some data was backed up from these assets and it was locked over here. Now, in a regular scenario, if a second copy is required, then replication is the way which is utilized to have like 2 copies or 3 copies or 4 copies, whatever, right? They would be replicated to a different backup server over the wire, and that same data would come here. Now, let's imagine if this locked state of this data set, okay, is not replicated to the other side, right? And here it's unlocked. Then attackers can simply target this system and destroy these data. And later, when there is a problem in this guy, okay, this server, you have no reliable copy left because this was never locked. So we don't know whether it was tampered, it was deleted, or what was done with it. We cannot guarantee that this data is same as this data, right? So replicating the lock state along with the data is very important to ensure that we have a reliable second, third, or fourth copy, right? So that's where this, along with the data, the lock state also gets replicated, and the same file is locked here. Nobody can come and tamper this, nobody can come and delete this. So you always have a second good copy.
Jagan, one point. The SEC regulations require a protected second copy. Without the second copy, it will not be compliant. That's one of the compliance requirements.
It's a mandatory requirement. So that's the importance of immutability in replication. Other one is a more advanced scenario where we have air-gapped cyber vaults. Okay, so this is quite similar to the earlier replication scenario we saw. But if you see here, right, this air gap, okay, this second copy backup server, this is completely cut off from the network all the time, and this vault itself controls when the gap has to be closed. That is, when the data has to be synced from the other side, it will close the gap, okay, and the data will flow in, and then it will open the gap again. It's completely cut off. So one nick is like it's based on firewalls, or it depends on the vendors who implement it. It can be any kind of cutoff. But nobody will be able to manipulate the data in any manner. Now, once the data comes in, then they have their own point-in-time locking the data, making point-in-time copies, or whatever required. In this Dell model, we even have CyberSense, which is like AML analysis tool where the data that is backed up is also analyzed if it is an encrypted ransomware copy. Because at that point, there's the first bad copy that is incoming, and we need to detect it and flash all the alerts that something is wrong and take corrective measures or restore the correct copy. And in the event of such an attack, there are other things like a landing zone or a clean room where the last good copy can be retrieved to and sent back to the primary backup server or to the as a primary data back to the clients. So that is also possible. But this is one of the most popular models nowadays because this provides a more isolated backup methodology, right? Which is like not accessible to most of the attackers outside. Yeah, I think I had that. Any questions?
So I've had the pleasure of flying to Singapore to do a few investigations. What I found notable in a couple of them, and these are ransomware kinds of scenarios. One, they gained access to the backup server, actually in this case multiple.
Yes.
And what they went after was not the data, they destroyed the catalog, the backup catalog.
Yes.
And which rendered basically
Useless.
all of the backups, and it was a near instantaneous kind of attack. So that was one of them. With some adjustments, same organization got hit again, and they had they thought that they had protected themselves by backing up the backup server.
Yeah.
So backed up the catalog server, and in this case, we're talking about organized crime here. Yes. The attack was same approach. Don't really want to delete the data. They effectively found a way to destroy the server, rendered it inoperable, and in this case, they did the same thing on both backup servers. And again, your backup is no longer there. And then this was the first stage of their attack. And while IT was trying to figure out why two backup servers were suddenly dysfunctional, they executed the ransomware attack. There was no recovery. So, that's when you were talking about sort of threat vectors, it was sort of implied that, what you're trying to protect on the backup servers is essentially this. But the point I'm making is, the one scenario where you show the air gap, that's not visible during the attackers are doing reconnaissance, and therefore they may never have seen it.
Yes.
On the other hand, if you're using identical hardware and software, and they are able to kill one of these, they're all subject to being killed if they're reachable. And some of the mechanisms that are being used are pretty advanced, and a lot of the security mechanisms you said, those are all great, but there are ways to bypass that stuff due to vulnerabilities and whatnot.
Thank you, Eric.
So to Eric's point, here, when you have a replication, our experience is that these hackers, they can stay undetected for like 6 months, 8 months, and they figure out where all the copies are going. They make if you have a 2-copy situation, they detect all the replication destinations, and they go to those first. And that's why we came, so if the data gets encrypted here, and you have a replication turned on, the same bad encrypted data will go and land here, and it's of no use. And that's why this is becoming very popular, the air gap. With the air gap, what happens is, when the data lands, lands in a special place, a landing zone, right? From that landing zone, what we do is we run this software that tries to detect all known signatures. And once we flag that the landing zone is clean, only then we will move it to a for replication to land, that landing zone needs to be exposed, right? As long as the air gap is closed, the landing zone is exposed. But once we make sure that the landing zone is clean, then we move the data to another location in the server that is not exposed to anybody, right? And once we move there, which is another hidden path, and there we retention lock it. The data can be retention locked here, but we have a separate retention lock, what we call PIT copies, point-in-time copies. There can be multiple point-in-time copies, and they're all, guaranteed to be clean. And that's where this air gap is becoming very, very popular these days.
So I have a completely different question. Because some of this is being driven by the regulatory space.
Yes.
Especially our friends in Europe, not only do they want to see protection, so immutability is being required for certain kinds of information. The other facet of this is it must be gotten rid of. So not only do the shackles come off of the data, but then you have an obligation to basically eliminate it with acknowledging that there may be a legal hold in place, although that's hugely an American kind of thing. But certain networking information, for example, telco and cell phone carriers are required for anti-terrorism purposes. They're required to keep some of this information, but then they are required to eliminate it after this certain period of time, and they want to see proof that that's being done. They're coming in and they're auditing, and if you screw this up, the penalty's pretty nasty.
Yeah. So
how do you deal with that?
So yes. So the file system itself doesn't delete anything. We've made the copy data management, the software, the backup software is responsible for deleting, but to the point, we have to offer guarantee that the data is deleted when they actually deleted it. So we, the sanitization that you talked about yesterday about at disk level, we also have sanitization at the file system level, right? So, but that doesn't guarantee that at the disk level. So there is a requirement that says at a file level, can we guarantee sanitization at the file level, right? That we haven't implemented that yet, right? So you could do sanitization at the file system level, you can do sanitization at the disk level, but you are correct that they are asking for sanitization at a file level, right? We haven't gotten that far yet. And about where you mentioned that the catalog is the first thing that they delete, so that it doesn't matter whether you have a file system or not, if there is no catalog, you cannot find your data. So what we do is that the default is that every hour, the catalog itself is backed up to the file system and retention locked. And we also have something called a reconciliation process. If there is always a delta between the two catalog backups, and if we need to recover it, then we can go to the file system, because with every backup, they also send some metadata information along with the backup. And using that metadata information, we can actually put together the catalog back. So that's a slow process, because we have to walk the entire file system, and every single file we have to walk and get the data, get the metadata, and recreate the catalog. So that feature is also available. I mean, it's not unique to Dell. There are a lot of vendors do that. They are self-describing backups. That's what they call them. And that's it. That's all we have.